So in Rutherford alpha scattering experiment, gold foil experiment. So what is happening here? You can see, this is the second diagram. This is the second and this is the third one. So here, this is source of alpha particle. We can take cesium or plutonium. Okay, polonium, cesium or polonium. That is a source of alpha particle. Then we have these are the lead bricks, and alpha particle goes through this and hits on the gold foil, thin gold foil. And then what happens is gets scattered. Okay, all the rays get scattered in different directions. Okay, now, so this is the backward scattering of very small fraction in 10,000, like 1 in 10,000. Now, this is suppose when the rays alpha particles are going very close, then what happens? The deflection is more. As they are moving away, deflection is very less. Okay. Next, after that, we have like number of scattered particle versus scattered angle. So here, what happens is, here the number of scattered particle and scattered angle is at 0 degrees it is very less. At 180 degrees, 0 degree, most of them are going straight, and very few are going through 90 or 180 degrees. And to this we can also use the formula. See here, this alpha particle is approaching the gold foil. So we can again use the formula that is force of electrostatics formula. F is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by R square, where Q is ZE is the charge of the nucleus, and E is the charge of the electron or whatever it is. So now we can take for alpha particle to be 4e. If it is alpha particle, 2e. Okay, 2e ZE. Z is for the nucleus. Z is the atomic number of the gold, and F is equal to 1 by 4 pi epsilon 0 ZE square by R square. Clear with you? Is this clear?
Yes, sir.
Yeah. Okay. So we will go ahead now with the board's model. Okay. So we started this was the. So we'll have to discuss about the conclusions of this particular conclusion. This is explained from the graph only. After that we have electron orbit. So there are three formulas for electron orbit. Okay. Now, so we have energy. So first, let me calculate the radius, velocity, and energy of the orbit. Okay. So these three derivations are not there now. Only the formula they are asking. Qualitative explanation. Only the formula. Okay. So before that, I would like to go to the Bohr's model. Okay. I'll discuss the Bohr's model. Then we will discuss the formulas related to that, and then hydrogen atom. These three we have to discuss now. Okay. So right here. Now here we have Bohr's model. So in Bohr's model, it says that, see, he's the student of Rutherford. Okay, so this is the nucleus, proton and neutron, electrons are revolving around the nucleus. Okay. Now, see here we have n is equal to 1 is equal to k, n is equal to 2 is equal to L, n is equal to 3 is equal to M, and we have n is equal to 4 is equal to N. Okay. So these are the four different things. Okay. So here what happens? The first one, atom is spherical in shape. Atom is spherical in shape. First one. The second one is the entire mass of the atom. The entire mass of the atom is concentrated at the center part of the atom core, of the atom called nucleus. Okay, atom is spherical in shape. The entire mass of the atom is concentrated at the center part of the atom called nucleus. Yes. So, in the Bohr's postulates, we have our Bohr's model. So, atom is, he says that, just check. Atom is spherical in shape. The entire mass of the atom is concentrated at the center part of the atom called nucleus. The nucleus is positive in charge. Okay. So, nucleus is positive in charge. Nucleus is positive in charge. Fourth one, nucleus consists of protons and nucleus consists of protons and neutrons. Nucleus consists of protons and neutrons. Fifth one, electrons are revolving around the nucleus. In fixed orbits. In fixed orbits or stationary orbits. In fixed orbits or stationary orbits. Okay. Here. So, as the size of the orbit increases, the energy associated with the orbit also increases. Okay, as the size of the orbit increases, the energy associated with the orbit also increases. Next one. So, the angular momentum of an electron is given by angular momentum of an electron. So for that reason only they give n is equal to 1, 2, 3, 4. Okay, they have fixed orbits. Okay, angular momentum of an electron is given by, okay, L is equal to what? L is equal to mvr, which is equal to nh by 2 pi. Okay, so m is the mass of the electron, v is the velocity of the electron, r is the radius of the orbit. Okay, n is the principal quantum number, h is Planck's constant. Here I will write here, m is mass of electron, v is velocity of electron, r is radius of electron, radius of the orbit, r is radius of the orbit, n is principal quantum number, and h is Planck's constant. What is the value of Planck's constant? That is h is equal to what? 6.624 into 10 to the power of minus 32 joule second. Okay, is that clear? So, so these are the values. Just note down this, then I'll go for the one more postulate, last postulate. When an electron absorbs energy, it jumps from lower level to higher level. Okay, so like this. So this is what E1, this is E2. Okay, so we have delta E is equal to what? E2 minus E1, which is equal to h nu. Next one. Suppose when an electron is jumping from, so it will be there only for a fraction of time. Okay, so when an electron jumps from higher to lower, lower level, it releases energy. it releases energy in the form of light. It releases energy in the form of light. Okay. So what happens when it is jumping here? So this is h nu. So this is E2, this is E1. So delta E is equal to what? Delta E is equal to E2 minus E1, which is equal to h nu. Okay. Yeah. So this much is the energy released. Clear? So, but he could not explain where he failed means he could not explain the that is he could only explain hydrogen atom, but other than hydrogen he could not explain like 2 electron model, 3 electron model. Hydrogen is 1 electron model. Only he could explain a 1 electron model. He could not explain the 2 and 3 electron models. Okay. Now, okay, done. Okay, so we will go to the next one. That is radius of the orbit. First one is radius of the orbit. The formula for radius of the orbit is what? Rn is equal to R is equal to h square epsilon 0 divided by pi m e square. Okay, h square epsilon 0 by pi m e square. That is a radius formula. Next is the velocity formula is the velocity. Okay, velocity. Second one is velocity of an electron in nth orbit. Velocity of an electron in nth orbit. Vn is equal to how much? It is e square by 2 epsilon 0 into n into h. The third one is energy of the nth orbit. Energy of the energy of an orbit. Okay, energy of the orbital or orbit. Energy of the electron in the orbit. Energy of the electron in nth orbit. Okay. So what is the formula for that? En is equal to minus m e power 4 by 8n square h square into epsilon 0 square. This is the energy of the electron in nth orbit. So now we have for the first orbit we have in general formula that is minus 13.6 by n square electron volt. This much is the formula. Okay, so these three formulas are very, very important because they can ask any question like direct substitution is there. Okay. After that, spectrum already we did. So did we do the de Broglie hypothesis? De Broglie in the starting?
No, sir. I don't think so.
No. Okay, we'll do the de Broglie hypothesis now, and we'll do some numericals also on this question. Mostly that hydrogen. Did I explain that hydrogen atom thing? Okay.
This one, right?
Which one?
This one.
हाँ वो वाला हाँ. So next one is de Broglie's Broglie wavelength. No, excuse me. Just copy this, then R into 1 by 2 square minus 1 by n square. So R value is how much? R value is 1.097 into 10 to the power of 7 per meter. This is the value, okay? And we have C is equal to nu lambda. Mu is equal to R into C, 1 by 2 square minus 1 by n square. That's a point. Okay. Okay, so this is about the spectral series formula. Okay. So we can do is start solving some numericals on this one. You start with this one, the first one, this which came in the board exam. This one, 12.2 came in the board exam. Okay, just try this. 12.2.